Okay, question 4. Solve algebraically the equation. So again, solve algebraically, it just means don't guess. So no marks for guessing, unfortunately. So yeah, solve algebraically. So what we're going to do first, I would suggest, first of all, we break out this bracket. Okay, and again, if you're not sure what to do, just try and do something. Okay, because you might just start working and think, oh, wait a minute, I can do more than I thought. Okay, so let's break that bracket out. Okay, so 6x minus 6 minus 12. Okay, we can then group these terms, can't we? So that's 3x is less than 6x minus 18. And I think I want to get the x's all onto one side. Okay, so what I'm going to do is take away 3x from this side, which means I'll have to take away 3x from this side. So I'm going to have 0 on this side, less than 3x minus 18. Okay, so that's me grouped all my terms. And then I want to move 18 over to the side, or 3 over to the side, but I'd like to get something on this side. So if I add 18 on here, I have to add 18 on here. So I'm going to end up with 18 is less than 3x. Yeah. And then I'm going to divide. So to get rid of 3, I'll divide both sides by 3. Divide by 3, divide by 3. So obviously 3 would cancel on this side. And this side is going to become 18 divided by 3, which is 6. 6 12, 18 is less than x. Okay. Or x is greater than 6. Okay. Yeah, I suppose maybe what I could have done actually, maybe at this point I could have taken off 6x, so that became minus 3x. Maybe I could have done that actually. That'd been fine. The whole point of this is that it's the exact same as an equation. This, you could treat that almost like an equal sign, almost. Okay, so what we do to one side, we have to do to the other. It's all about moving it over. We do the opposite action effectively. Okay, so on here, for example, I wanted to move minus 18 over. So you can think of that as two ways. You move it over and change the sign, so minus 18 becomes plus 18, or you have to do plus 18 on both sides, so then that would cancel and it becomes plus 18 over here. The only rule you need to remember is if you divide by minus 1, your sign flips. Okay, it's the only thing you need to remember here. Okay, so if we do anything but we divide by minus 1, this goes round the other way. I think some people might have made the mistake by moving this over, thinking I need to divide by minus 1 now. Okay, but you don't. So when you divide by minus 1, that's when it changes. So what we can do as well is just double check to see if it makes sense. Alright, so if we're saying that x is greater than 6, okay, let's see what happens if we put 6 in. So if we do, let's do this in a different colour pen. 3 times 6, that gives us 18. Less than, so 6 minus 1 would give us 5. 5 times 6 would give us 30. Take away 12, so that gives us 18. So that's not true at that point, is it? But the minute x becomes bigger than 6, this would become true. Okay, so yeah, you could try it for 7. Right, so let's try it for 7. So 3 times 7 is 21, is less than 7 minus 1 is 6. 6 sixes are 36. 36 take away 12 and give us 24. So 21 is less than 24. Okay, so you can check to see if you've got the right answer as well. Okay, I'll just rub that. So yeah, that's looking good to me. Okay. So yeah, just double check it at the end. Oh, sorry for the marks. Okay, so you're going to get a mark for breaking out the bracket. So again, if you know nothing about equations, you can still break out a bracket. Okay, so that's brilliant. Collecting the terms is going to get you a mark as well. So by moving this 6x over here and having minus 18, that was worth a mark. So I've done it a slightly different way. So maybe at this point you'd be getting the mark and then just your final statement, okay? But collecting like terms, so minus 6, take away 12, and then 3 minus 6, that's worth something, okay? Yeah, that's fine. Oh, in fact, at this point, what I could have also said was take away 3x to move the 3x over here. So that would have been minus 3x is less than 18. So if you've got minuses on both sides, they would just cancel out. Okay, so that's just the last thing. Okay. Question 5. I love these questions. I think the standard deviation questions are about as good, or the data analysis questions are about as good as you can really get. it's very prescriptive. It's the same questions over and over again. So if you're looking for some easy marks, I would suggest looking up at this, okay? So farmers market took place one weekend, and the stallholders are asked to record the number of customers who visited their stall. The number of customers who visited 6 of the stalls on Saturday were as follows. Okay, so this is the number of people that visited a stall at a farmer's market. Okay, so one stall got 120, one stall got 126. Okay, so calculate the mean and standard deviation of the number of customers. Okay, so the first thing I would do with these, I always like to just write it in order. Okay, you don't have to, but I do just like to do it that way. So 120, 124, 125, 126, 130, and 131. It's just helpful, okay, for me anyway. So the mean is adding all these up and dividing by 6, okay? So it's going to be, say, x bar is the mean, so that's equal to 120 plus 124 plus 125 plus 126 plus 130 plus 131 divided by 6. Now 6 is what we would say is n, okay? So we do that in a calculator. Okay, so that gives us 126, which to me makes sense. Okay, I'm looking at that and I'm thinking, yep, 126 is about mean, it's kind of in the middle. The thing to watch out here is to make sure you put this in a bracket. Okay, if you just type this out in your calculator and then divide by 6, it will just divide the last term by 6. Okay, so you want to have that in a bracket in your calculator. And again, check the number, does it make sense? Okay, so we know that x bar is 126. Now, if we go to our front page, we're going to get the equation for standard deviation. Okay, so standard deviation is equal to the square root of the sum of x minus x bar squared divided by n minus 1. Okay, so it looks really complicated, really mathsy, right? But it's not really. So what we need to do is just make a little table, and we're going to work out our x minus x bars. So out of a table where I say I've got x, okay, well, let's just do just a little line along here. Okay, so that's kind of straight. Still technical difficulties with my use of the pen. That looks good, doesn't it? Yeah. Okay, so we've got all our x numbers. Okay, so x is just the numbers we're given. So we've got 120, we've got 124, 125, 126, 130, and 131. Again, this is why I like writing in this order. Just the numbers look nicer, and I think it's easier to make a mistake when you don't have it like that. Okay, so that's our first one. The next section we're going to do is x minus x bar. Okay, so in here we're going to do x minus x bar. So it's just the difference from our x number to our mean. Okay, so 120 take away 126, going to give us minus 6. 124 take away 126, minus 2, minus 1, 0, plus 4. Is that right? Yeah, plus 4, and 5. Okay, now here's a little trick. Some people, because we're going to square this term next, it doesn't really matter what the signs are, they're all going to go positive. Okay, so some people just kind of look at the difference, so they just say 6 squared, 2 squared. Okay, but I like to actually keep the signs in, because if we sum this column up at the bottom, right, what do we get? We get minus 6, 7, 8, and 9, and positive 9, so that comes to 0. Okay, if you get a 0 down here, it means you're doing it right so far. Okay, if you don't have a 0 down there, you've made a mistake somewhere. Okay, so that's quite good. So the next term is our x minus x bar all squared. So again, looks like a really complicated table, but it's not. It's just this number squared, isn't it? So 6 squared, 36, and these are all positive numbers. 2 squared is 4. 1 squared is 1. Don't make the mistake of messing that up. 0, 16, and 25. And then we just add them together. So that's 40, 41, 51, 57, and then 57 and 25, be 70, 82. Okay, I'm just going to rub out a little scribbling in there. Oops, that big. 25. Okay, so that sums up to give you 82. And that's kind of the back broken on the work actually, because now if we go to our equation, we've got s is equal to the square root of the sum of x minus x bar squared, which is this number in here, which is our 82, because we just added up all of the x minus x bar squared. Okay? N minus 1, so we've got 6, we said was our n, because we've got 6 numbers. So n minus 1 is just 5. So the square root of 82 divided by 5. So let's get the calculators out. And again, you could just do a bracket, just to be sure. 82 divided by 5. So that's giving me 4. Oops. 4.05, I'll call it. Okay. So that's the standard deviation. Again, just make sure you maybe write these things in English as well, just to be clear for the marker, or kind of highlight it in a way. I mean, I like the double underline. Is a good way of doing it. Ideally, you would kind of have it onto one side. Obviously, my writing's quite big, I can't do that. But the point is just try and highlight where the answer is for the marker. Okay. So 126 and 405. So 4 marks for that, and really, it's it's pretty easy. So you're getting a mark for your 126. Okay. You're going to get a mark for calculating your x minus x bar squared. So it looks like they're giving you a mark for basically this table, and then you're getting a mark for substituting into the equation, and then a mark for actually doing it. Okay. So yeah, not a tough question at all. They give you the equation. You've just got to know just to split it into this, and there's a wee trick for seeing if you've got it right as well. Okay. This is where folk usually struggle. Okay. Is actually thinking about what we've just worked out. We should have enough time for this. I'll maybe just speak through it. So what I would say, the mean was 126, the standard deviation is 405. So it was 126 for the mean, 4.05. And this, so the mean number of customers on the Sunday, the next day, was 117, and the standard deviation was 6.2. Okay, so that was Saturday, and that was Sunday. Okay, so what's happened to the mean number of people between Saturday and Sunday? Let's see. So messy. Between Saturday and Sunday, well, it's obviously gone down, hasn't it? Okay, so the mean has gone down. Okay, what's happened to the standard deviation? It's gone up. So standard deviation has gone up. So does that mean the results are more or less consistent? Well, the less consistent, a smaller standard deviation means we've got a tight pack of results. So we've actually got a less consistent results. Okay, so the mean's gone down, and the consistency has also gone down from Saturday to Sunday. Okay, so to put it into a sentence, we really need to reference. I'm running out of time, so I have to be quick. Have to reference the question in its entirety. So we're looking at the number of people who visited. Okay, so I would say the mean number of people who visited on Sunday was lower than Saturday. Okay, and I would say the consistency of the visits was lower on Sunday than it was on Saturday. Okay, so the phrase I've always thought of it as well is on average as well. Okay, so on average, just to put that into words in, so on average, the number of customers or people visiting was lower on Sunday, and then say the number of customers, just write the word number, I'm just saying I know to save time, the number of customers on Sunday was less consistent or more varied, or there was a bigger spread, okay, something like that, okay. So less consistent, more varied, there's a bigger spread of customers. So on the Saturday, there was quite consistently 130 people almost at every stall, whereas on the Sunday, some stalls were having 150, and then some stalls were having 110. It was that kind of less consistent approach. Okay, right, good stuff.